In this module, we will describe how to add optimization objectives to your rapid plan model. Once the model has been trained and reviewed, the second step is to add optimization objectives to the model. These optimization objectives will be automatically loaded in the optimization dialog when you select the rapid plan model to create a plan for a new patient. Default objectives were added to your model when it was created. These include an upper and lower target objective and a line objective for all structures added to the model. You may want to make changes to these default objectives to achieve your clinical planning guidelines. The objectives you see here are example objectives for our test prostate model. Many of the objectives can be added as an absolute dose or relative dose. The relative dose implementation allows the objectives to be scaled such that the model can be used for multiple prescription doses. Let's start with the PTV. The example objectives for the PTV are that 100% of the PTV volume will receive 103% of the prescription dose, and that 0% of the PTV will receive 105% of the prescription dose. These objectives are based on our clinical planning experience. You may want to change these objectives to achieve a plan that meets your clinical guidelines. There are 6 optimization objective types you can choose for an organ at risk structure. The first objective type is a line objective. This objective will place points along the DVH estimated by the model for the selected structure. The current implementation does not place points in the region where the selected structure overlaps the target. As a result, you may want to add an upper objective to this structure to control the maximum dose to the structure in the overlap region. Please note that there are 2 options for the priority. 1, that it is generated automatically based on the model, and 2, that you can generate it manually by deselecting Generate. It is not recommended to mix and match priority types within the same model. Either use manually selected priorities or automatically generated priorities for all targets and structures in the model. The second objective type is a mean dose objective. This objective will work to achieve a specified mean dose, either an absolute or relative dose. There are 2 options for a mean dose specification. 1, manual specification of a mean dose, and 2, a mean dose generated from the model, which is the mean dose of the estimated DVH for this structure. Once again, you can either specify the priority manually, or you can allow the model to generate a priority for you. An example of when you may want to use a mean dose objective would be on the parotid glands in a head and neck model, where the specified clinical objective is a mean dose. The third objective type is an upper objective. This objective can be used to place an optimization objective at a fixed dose and fixed volume. This objective might be used to place a max dose objective on all structures in the model. For structures where the only clinically relevant dose is the maximum dose, such as the femurs or spinal cord, you might remove the line objective and only place an upper objective at these structures. The fourth objective type is another type of upper objective. The difference here is that the volume will be generated by the model based on the volume of the estimated DVH at the specified dose. In other words, this generated volume will be an achievable value derived from the model for a specific patient. You may use this objective type if your clinical guidelines for a structure suggest that the volume receiving a specified dose is less than a certain percentage. The fifth objective type is again another type of upper objective where the dose will be generated by the model for a specific volume percentage based on the estimated DVH. The last objective type is an upper GEUD. This optimization objective defines the maximum equivalent uniform dose value that a structure may receive. If you set an A value equal to 1, this corresponds to a mean dose. For A values greater than 1, higher doses are given a greater priority. In addition, you can add upper, lower, and target GEUD objectives for target volumes. It is also necessary to set parameters for the normal tissue objective. The default value is set to automatic NTO, where the model configures the parameters for you. There is also an option to set your own parameters. This is unchanged from the standard Eclipse treatment planning system. In addition, the implementation of the smoothing parameters is the same as the standard Eclipse treatment planning system. The ability of the model objectives to achieve clinically acceptable treatment plans will be evaluated in the validation of the model described in a subsequent module. These objectives should be adjusted until an acceptable set of validation plans is achieved. At this point, save your model and proceed to model validation.